You press enter and you just put the LN
No, it would have like LN and the number. Or we just put that on the calculator.
Yeah. You can do change of base on it. So if you have, like 22 was natural log of 247. If you have to do change of base, you would do log 247 divided by log. And what's the base here? If there's no base, the base on this one is 10, yes. But I do that because my calculator, if I just push log, it automatically goes to log base 10. And ln is log base e.
LN is log base.
There, what did you do? Go over to num? Okay, mine ends at 0. So, but yeah.
You go down to math, I'm in math, and then just go down. Until it says log base. Oh yeah.
But make sure you understand how to do this, the change of base. I assumed that was yours. It was under, yeah. I'm sorry. I had a meeting that was supposed to only last a few minutes, but it ran over. I got back about 3. Did we turn in yesterday? Oh, get it back? Yes, yes. I'm going to grade it and then I'll hand it back to you.
Is it grade on correction?
Half and half. The classwork, yeah.
Oh yeah, there is log base.
Why didn't you give it to me yesterday? All right, what else from your homework? Is that it? We're actually looking. I'm not going to spend an incredibly immense amount of time on this because it's not hard. You just have to practice with it. And that's why I'm trying to do classwork and homework to ensure, because some of you just copy on homework and it's not helping you understand what is going on. Precisely, right, Carter? Precisely. Precisely. So, what?
Why did you come to me?
Because I said some of. Okay, let's talk about logs. We're talking about log properties today, and we're going to use the log properties to expand and condense these log expressions. So I ran you a reference sheet to use so that you can, if you want to put your notes here, if you want to do it in your notebook, however you would like to best do it is fine with me. But just so you have something to kind of look at as you go through trying to work through some of these expanding and condensing. All right, y'all ready?
Let's not be like a fraction thing, like 100 to the 1/2. Would that be a square root?
If you say that again, 100 to the 1/2. Yes, that is the square root of 100. The third root. That's correct. That's correct. Y'all remember that?
Oh wait, what if it's like 5? Yeah, 5. Oh, I didn't get those right.
Y'all remember Sunshine?
Wait, actually, I think I do remember this. I remember you saying something about Sunshine.
What's the sun? Oh, if it goes in the shade, it goes in the sun.
Mm-hmm. So if this is a sun, in this form, the 3 is in the shade, the 2 is in the sun. So when, okay, you have to, if you, yeah. I don't remember.
Oh, that actually kind of makes sense.
So if they're in the sun in one form, they're not in the sun in the other form. It's stupid, but it helps you remember it. It's real stupid. So look at them here. Okay, in this form, the 2 is exposed to the sun, right? Well, this three is in the shade, right? Because he's got a hat on. He's in the shade. So over here, the 2 is in the shade because it's under the radical. But the 3's outside. So, yeah. On the second form, yes. If you change forms, they switch who's in the sun. It's just a stupid little quirky trick to remember, because nobody ever remembers which number goes where. Okay. As James misses his mouth and throws pretzels across the room in the opposite direction of his mouth, let's talk about... Okay, let's talk about log properties. First one, our basic properties here, you have 2 of them. You have one that says log base b of 1, and then you have another that's log base b of b. So if this value is ever 1, what does this always equal? 0. Why is it 0? That's exactly right. Y'all are right. Anything raised to the 0 power always gives you 1, with the exception of 0. If it's not there, yes.
Yeah, if it's not there, then it's what? Since there's a bigger than it's not.
If the b is not there, so if you have the log of 1, then, or, okay. I'm slightly impressed that y'all remember all this about logs.
I like logs.
If it says b, if b is there, then b is whatever it says it is. But if it's not there, it's an imaginary 10. Because think about this, right? B raised to what power gives you 1? The only thing you can raise it to get 1 is 0. Remember those exponent properties? Anything raised to the 0 power is always 1. So no matter what this number is, if this is 1, it's going to equal 0 every single time. Yes. So what log base 12 of 1 is 0. Always.
Because you're raising it to the 1 power, and you can raise it to the 1 power.
Say that the other way. You're raising it to the 0 power. And anything to the 0 power is 1. Did y'all get to logs in Algebra 2? No. I know y'all did. I'm not talking to y'all. I taught it to y'all. Okay. Okay. Right. All right. If you get confused. All right. If you're changing forms from logarithmic, guys, from logarithmic form to exponential form, this is where we make our little e. This is all the little stupid stuff that I taught y'all last year with. But the base is e is b to the e. Golly, geez. B to the x equals a. So it makes this e for exponential. B to the x equals a. You remember that? So you have to make the e to change the form to exponential.
So is that change of base form?
This is log form. This is exponential form. This is not on your thing. This is what you were doing yesterday where I put it up there. A log is a function. It's a thing that happens to the number. It describes exponents.
E is just like a stupid thing.
It's like the
Yeah, you have to. It changes the form, right, into exponential form. These are exactly the same thing. Some of my kids from last year helped me explain this in a nutshell. What helps you understand the way you have?
E connects with LX. I don't even listen to this. During the whole test, I thought that's what I was supposed to do. Well, I started writing logs and stuff, and I was like, this
Okay. Important things, take away from yesterday. The most important thing from yesterday was being able to evaluate the log, knowing what a log represents. So you should be able to go from here to here without any trouble, or backwards or forwards. Okay. Okay. Evaluating is telling what it equals. So, but you have to kind of think about it going. So in other words, if I said evaluate this. Why does it equal 3, Lucy? You're asking yourself, what power would I have to raise 2 to in order to get 8? That would be 3. You could. Change of base says if you have anything in any base, it doesn't matter because your calculator operates in base 10 because we're on a base 10 number system, right? Everything we do is base 10. Our numbers go 1 through 9 and then they start repeating at 0. Right? Open the door. I don't even know how to.
Oh yeah. He was next to me, but he threw me.
Okay. Change of base just allows us to have any base in the whole wide world that we want. And all it does is it says whatever you have, so log base 3 of, 12. Because I don't know a power that I can raise 3 to get 12, it's not a whole number, right? I can use my calculator and say, okay, well, I can do log 12 divided by log 3, and that'll give me the value. And it doesn't matter what base is here, it can be any base. I could do natural log of 12 divided by natural log of 3. Because that's a log base what? Natural log has a log of a base E. So the natural log, you know how I said if you have log of X, that means there's this imaginary 10 here. Well, this means it's a log with a base of E.
A question would be like, what is log 12?
Well, your calculator does have a natural log button. You see the LN button on there?
Why don't we just do?
Why is it not in L?
That would
Natural log, why is it?
logarithm de naturel. I don't know. No, I don't know. I'm just making that up, Lucy. I don't know. Yeah. It will give you the same. Yeah. Same thing. Yeah. That's fine. That's fine.
One is that Ellen is natural.
Ellen is a natural, another one's common.
What's natural log mean?
Natural log means like
Basically, original, like,
Has a base of E. Whereas regular log has a base of 10. You good? Yeah, you probably should jot that down. Yeah. All right. Back to today's. Property number 1, it doesn't matter what the base is. If this argument is 1, it's going to equal 0. Does that make sense why now? Because anything to the 0 power is 1. What happens if the base is the same as the argument here? It's just 1. And in fact, an extension of this, what would that equal? Sorry. Think about it carefully. Think about it, reason through it. B to the what power gives you b to the x? X. X. It's just x. B to the what power gives you b to the x? Whatever that exponent is, if these are the same, it just leaves you with the x. Is this coming back to y'all a little bit? All right, look at the example. There are 2 examples there. The first one, log base 6 of 1 is, of course, y. Here. I like this little sheet because there's an example with a regular log and there's an example with a natural log, so you can see 2, or it's supposed to be. All right, example 2 there, log base 4 of 4. 1. Look in the 3rd and 4th column up top, first row. All right, is everybody okay? All right, let's do the 3 proper. Oh, we did the change of base already. It's down at the bottom. Skip down to that last row. Let's do that before we do the new stuff. Change of base. Log base b of a. What do you do to change the base here? There you go. It's always the number that's written the biggest divided by the number that's written the smallest. Okay? I don't say the biggest value because you could have smaller values, right? If you don't know this one off the top of your head, do it.
Or whatever.
Fraction. Hit math, enter. Fraction. Why?
Because the second or the square root of.
There you go. It's the square. 36 to the what power gives you 6? I'm sorry, I didn't hear you. I wasn't ignoring you. You can put it in your calculator, but you might have some non-calculator problems that you'll have to do to be able to know. So 36 to the what power gives you 6? Yeah, it's not on the, I was just doing an extra example. Thank you. Math, so after you hit enter, then hit math, enter. But normally it will, so if I have this say, all right, does that make sense on this one? Why it's 1/2? 1/2 is the square root. Everybody okay? Yeah. Okay. Let's do the product property. You want me to do those? What's log base 5 of 138? Can everybody get that on your calculator? Calculator. So, there you go, Robert.
Oh, okay.
Just doing what we say, right?
Well, I got 3 points.
Yeah. How about log base 14 of 2? what? These won't be exact numbers. If they're not perfect roots of the number, they won't be. Yes, no, maybe so. Everybody okay? You want your homework now? You want my homework or the classwork? Yeah, this is all from the first one's the classwork. All right. Product rule, and I promise this won't take as long as what the others did. We're almost done. Product property. Really, logs are what? It starts with an E. We said this over and over and over in Algebra 2. Exponents. So properties of exponents apply to logs because logs are exponents. Logs always equal exponents when you're in your exponential form or logarithmic form, wherever it went here. The log always equals the exponents, right? Logs are exponents. So if you remember that, it'll make these properties a little bit easier. The first one, log base b. If I am multiplying inside here, my base is the same. If you are talking about exponents and you multiply two things that have the same base, what do you do with those exponents? In other words, I multiply, let's say I multiply this. You add the exponents, right? I'm going to do the same thing here. To expand this out, I split it up with addition. Keeping the base the same, but I add. If I go from left to right, that is expanding. If I go from right to left, that is condensing. Write it in a bigger form as expanding, simplify it down and shrink it down as condensing. And that's all. And there are only 3 properties. That's one of them. Yeah, you leave it. You leave it expanded out. So let's do the 2 examples on here. Look at the first one. The first one says condense, and you have log base 3 of 8 plus log base 3 of 3x. How would I condense that? In other words, put it together. Log base 3. Now notice what happens. I'm going to leave the log written one time, and I'm just going to multiply these values together. So log base 3 of, which is 24x, and that's it. Go ahead. They have to have the same base. That's the rule. You can't condense it. You would stop. If this was 7, I can't condense it any further. I stop. Just like properties of exponents, they have to have the same base. That's the key. If I started with this and I told you to expand it, is it already expanded as far as it can go? No. What could be expanded further? The 3x, because I'm multiplying here. Do you agree? That's right. I could expand that into log base 3 of 3 plus log base 3 of x. What is this? That's 1. Why is that 1, Lucy? You're right. The number's the same, right? That exponent's 1. 3 to the what power is 3? 1. So really I could rewrite this as that makes sense. Okay. What is terrible? How did you know? Okay, for expanding, For expanding, I've only shown you the multiply one, the product one. So I'm looking for something to be multiplied. And as I looked at this, I went, but nothing's being multiplied. But oh my gosh, I could change it where something is being multiplied, right? How could I do that? Factoring. Factoring. Was that this class that I was being observed and I said it's our favorite F word? Was that this class? Okay, factor it. This is a shortcut factor because there's no leading coefficient. It's okay. It's okay. This is a quick one just because the leading coefficient is 1. But if you need to do it long ways, you most certainly may do it long ways. No, because what? I got to expand it. So what's being multiplied? And then what? Yes, absolutely. That's it. Splitting up multiplication, that's all expanding is there in that one. Everybody good? Quotient property. When you are dividing with the same exponents, what do you do? Subtract, that's right. If I'm thinking in terms of if I have something like this, the base is the same, what do? I subtract, right? So I'm going to do the same thing with logs because logs are exponents. So if I have log base b of m over n, no, it's literally falling asleep as you sit straight up. I can split this up, log base b of m minus log base b. Expand from left to right. Condense from right to left. And I promise I'm almost done and I'll set you loose. Actually, yes, I was waiting on someone to finish their test, and she just came back and finished today. Yes. All right. No, it won't be. Just on the test. Yesterday's, what you did after the quiz yesterday. Yeah, what you did yesterday after the quiz, like what you had for homework last night, what you have for homework tonight, and then what you have for homework tomorrow. That'll be on the test, but that won't be on the homework quiz. We leave you out on things. We're literally having like a class discussion. Okay, so what we did yesterday after the quiz, what we're doing now, and what we'll do tomorrow. We'll be on the quiz on Thursday. Yeah. Not what you had on the quiz yesterday. What you had on the quiz yesterday will be on the test we have for the unit. Everybody good? Okay. Look at the first example here. Condense the log of 80 minus the log of 16. I don't see a base on here. What does that mean? Yay. It's 10. I thought it was you, Noah. I thought Noah said that. Okay. So I do log of 80 divided by 16. Now you can divide them both by 8. Even bigger. Right? How can I simplify 80 over 16? It's just 5, Robert. It's just 5. All right. It's in your hair.
It's the very end of it. You literally. Other one.
Yes, I keep a stack of them by the printer. Let's expand. What does this look like expanded? Questions on quotient property. Are we okay? Hope it's all coming back to you. It's all coming back. It's all coming. Power property. I have log base b of m to the n. If you are talking about exponents and you raise a power to a power, what do? You multiply. I'm going to do the same thing here because I have a power because logs are exponents. Raised to a power, I am just going to bring that thing around front and multiply. This is the easiest of all the properties in my opinion. It just comes around front and multiplies. Or it just comes. Okay, so, okay, we'll look at it. All right, expand. Of course, same thing. Expand, condense. So I have 3 log 9 that I am asked to condense. That'd be 9 to the third. It'd be natural log 9 to the third. And I could even take this further and say 9 to the third is, that's right, power property. How do you expand that one? These are the kind of things that throw calculus kids off all the time. That's why I think it's important we take time to do it. It's never the calculus.